Hello everyone. In this video we are going to discuss about conversion of LU to MPCP. In the previous video we have discussed about MPCP to PCP conversion. In this video we are going to discuss about Turing machine to MPCP conversion. So given LU, that is the Turing machine is represented by M comma W, where M is a Turing machine representation. So M is equal to Q sigma gamma delta Q naught BF, and this W is an input string. That means W is in sigma star, means we can construct an equivalent MPCP instance A comma B, the two list A and B. So if Turing machine and the input string is given, means we can construct the MPCP instance A comma B. So the Turing machine M accepts W. The Turing machine M accepts W if and only if the MPCP instance A comma B has a solution. So the Turing machine is given, means we can construct the MPCP instance by using the 5 rules, and then we can check whether the Turing machine M accepts W and A comma B has a solution. So the first rule is, first pair of the MPCP instance A comma B is list A. In list A we have to attach hash, the separator hash, and list B we need to attach hash Q naught W hash, because this is the given Turing machine. So here W means the input string, this W means input string, and Q naught is the start state. So in the first pair, list A should contain hash, list B should contain hash Q naught W hash. And the second rule has to be written for the tape symbols. Here X means any tape symbol, but except blank. Blank will not be used for MPCP. So X means all the tape symbols except blank. So in list A we have to attach X, list B also we have to attach X. So because if Turing machine is given, means we are going to construct MPCP instance list A and B. This is a rule for first pair, and in the second rule we are going to consider all the tape symbols except blank. So first we have to attach X in list A, X in list B, then hash in list A, hash in list B. Then third rule is used for simulating moves of Turing machine M. Turing machine will contain several transition rules. So for each and every transition rule we have to use the rule 3. So here Q means it's a non-final state. Capital Q minus F, where Q means set of states, F means final states. So Q minus F means all the non-final states. So Q, small letter Q means non-final state, but P means any state. It may be both final and non-final state. And the notations X, Y and Z are the tape symbols. So here there are 4 cases. Del of Q comma X equal to P comma Y comma R. Then left move, B right move, B blank left move. That means case 1 is any tape symbol except blank right move, tape symbol left move. So tape symbol right move means case 1, tape symbol left move means case 2. Then blank and right move, blank and left move. So these are the 4 cases. So whenever we have a tape symbol and the move is right move, in list A we have to write QX. That is, we have to combine the current state and current tape symbol. So Q and X. In list B we have to refer the right hand side of the transition rule. For writing list A we have to check the left hand side of the transition rule. Here right hand side. That means P comma Y comma R, but in list B we have to attach Y and P. That means the tape symbol and then the next state P. Similarly, del of Q comma X equal to P comma Y comma left move. Any tape symbol except blank, and the move is left move, means then we have to consider here Z. Z is also a tape symbol but except blank. So Z QX. Okay, here we have to write just QX, but in the second rule we have to write ZQX, and in list B we have to write P, then the new symbol Z, and then Y. Here Z means any tape symbol. Suppose the tape symbols are 0, 1, blank. Blank we can leave it. For 0 we need to write one rule. Then for 1 we have to write one more rule. That means first we have to consider z as 0. Next we have to consider z as 1. That we will discuss it in example. Then third rule is if del of q comma blank equal to p comma y comma right move. Blank and right move means here in list A we need to write q and hash. Blank we should not write. So here we have written x, no, but here we have to write the separator hash. Then in the list B we need to write yp hash, right? The tape symbol, next state, and then hash. Similarly, del of q comma b blank equal to p comma y comma left move means similar to this left move. Second rule, here we have introduced z. No, similarly we have to write use z in the fourth case also. So we have to write zq hash. Zq hash. Here instead of x we need to write hash. Then p zy hash. P the new symbol z, then the tape symbol y, and then hash. So we can write third rule from the first rule by replacing hash by replacing x by hash. So q hash, here also zq hash. But in list B, just we need to append hash at the end. So yp hash, and here pzy hash. Then for the fourth rule, we need to consider q is a final state. Okay, here q should be a final state and xy are the tape symbols except blank. Okay, so in list A, for all the final states, we have to write the list A rules like this. And list B rules. Okay, list A rules means middle symbol should be the final state q, and it should be preceded and followed by tape symbols. So x, q, y preceded and followed by the tape symbol. In list B we have to attach the final state alone. Then another rule is tape symbol followed by the final state. Here the final state alone, and here final state followed by tape symbol. Here final state alone. Okay, so here the final state is preceded and followed by the tape symbol. Here final state is preceded by tape symbol followed by tape symbol. But in all the cases in list B we have to attach the final state alone. Then the final pair of the MPCP instances, in list A we have to attach q hash hash. Here q is a final state only. In list in rule 5 also q is final state only. So final state hash hash must be attached to list A, and hash alone must be attached to list B. Now consider an example. Let us convert the Turing machine M equals q1, q2, q3. These are the set of states. Input symbols are 0, 1. Tape symbols are 0, 1 and blank. Then delta is represented as a table here. Then q1 is a start state, blank is a special tape symbol, and q3 is a final state. And the given input string is w equals 0, 1. Now we need to convert this Turing machine into MPCP instance. So the first pair of the MPCP instances, in list A we have to attach hash. So first rule is we need to attach hash in list A, and in list B we need to attach hash q0 w hash. So hash q0 means start state of the Turing machine. So here the starting state of the Turing machine is q1. So we have to write q1 here. Then w, q0 w hash, right? So w means here 0, 1. So we have to write 0, 1 and hash. The source we will write for the rule 3. So the second rule, as per second rule, we have to attach x and x here. X means tape symbols. So here the tape symbols are 0, 1 and blank. So we need to attach 0 and 1 only. Okay, no blank. So 0, 0. Here we have to attach 1. Here also attach 1. So we have written x except blank. Then we need to write hash and hash. So here hash, here also hash. So second rule is also over. We will write source when we write the third rule. Okay, this transition rules we have to write it in source. So in rule 3 we need to consider all the moves of the Turing machine. So it is given as a transition diagram here. The first rule is del of q1 comma 0 equals q2 1 right move. So now we need to check which case? Okay, here we are getting tape symbol and right move. Tape symbol and right move means first case. So we have to write QX in list A. So Q1 0. And here we need to write YP. YP means here 1 and Q2. Similarly, for each and every transition rules, we need to refer the cases and we have to write the rules for list A and list B. So second transition rule is del of Q1 comma 1 equals Q2 0 left move. So here tape symbol and left move. So it is case 2. So we have to write ZQX then PZY. Z means first we have to consider 0 as Z, then we have to consider 1 as Z. So first 0, ZQX, so 0, Q1 1, then PZY. PZY means P means Q2, Z 0, then Y means 0. Then we have to write the same for Z equal to 1. So 1 Z1 1, Q2 1 0. Instead of Z, we have written 1 here. Next, we need to consider the third transition rule. Third transition rule is Q1 comma blank equal to Q2 1 left move. So del of Q1 blank equals Q2 1 left move. So here we are getting blank and left move. Blank and left move means case 4. So we have to write ZQ hash. So 0 Q1 hash, and here we need to write PZY hash. So Q2 Z means 0, Y1 hash. Then we need to write the same thing again, but instead of Z equal to 0, we need to substitute 1. Q2 1 1 hash. Next, we need to write the fourth transition, that is del of Q2 comma 0 equals Q3 0 left move. So this is a tape symbol and left move. So case 2. So we have to write 0 Z 0 Q2 0, and here PZY. P means Q3, Q3 0, Z is 0, Y is also 0. Then we need to repeat this for Z equals 1. So 1 Q2 0, then Q3 1 0. Okay, then the fifth transition is del of Q2 comma 1 equals Q1 0 right move. So this is tape symbol and right move. So tape symbol and right move means case 1. So here we have to just combine Q2 and 1, and here we need to write 0 and Q1. Then the final transition is del of Q2 comma blank equals Q2 0 right move. So this is blank and right move. Blank and right move means it's case 3. So in list A we have to write Q2 and hash, and list B we need to write YP hash. Y means 0, Q2 hash. In rule 4 we have to consider the final state. So the final state in this problem is Q3. So for Q3 we have to write rule 4. In list A we need to write Q3 in the middle, and X and Y are the tape symbols. So here the tape symbols are zeros and ones. Blank we should not consider. Okay, 0 and 1 are the tape symbols. So in list A we need to write 0 Q3 is a final state 0, then 0 Q3 1, 1 Q3 0, and 1 Q3 1. That means the middle symbol is Q3. It should be preceded and followed by the tape symbols. Here the tape symbols are 0 and 1. So we can get 4 possible combinations: 0 0 0 1 1 0 1 1. Then we have to write tape symbol and the final state. So here the tape symbol is 0, final state Q3. Tape symbol is 1 and the final state Q3. Then final state and the tape symbol we need to write. So Q3 0, Q3 1. Okay, so middle symbol is Q3, preceded and followed by tape symbols. Then tape symbol followed by Q3, so 0 Q3 1 Q3, then final state followed by tape symbol, so Q3 0 Q3 1. In all the cases in list B we have to attach the final state. So Q3 Q3, we should write it for all. Okay, list 4 is over. Sorry, rule 4 is over, and final pair is Q hash hash and here hash. Q means final state, so Q3 hash hash must be written for list A and hash must be written for the list B. So this is the MPCP instance for the given Turing machine, so that we can check Turing machine. This Turing machine M accept this input string W if and only if the MPCP instance has a solution. So we need to check whether the Turing machine M accept the input string W. So the Turing machine M accept W means we have to start with Q1. By using instantaneous description we can check this. So the start state is Q1 and the input string is 0 1. So Q1 0, Q1 0 means move is right move and 0 is replaced by 1. 0 is replaced by 1, move is right move, and the state is changed to Q2, then the symbol is 1, right? Move is right move, so we have moved the state 1 symbol right, and the state changed to Q2, 0 is replaced by 1. Then in the next step Q2 and 1, so we have to refer this. Move is right move, so we have to write the state here. State changed to Q1 and the 1 tape symbol 1 is replaced by 0. So here we need to write the same one, and here assume that the next symbol is blank. Then Q1 and blank, so we have to refer Q1 and blank. So move is left move and state changed to Q2 and the blank is replaced by 1. This 0 we have to write it here and this one. Then Q2 and 0. Q2 0 means move is left move. State change to Q3. 0 no change. Here write 1, here also 1. Then Q3 and 1. Q3 and 1 undefined. So the Turing machine halt. Undefined state means the Turing machine will halt. But we need to check whether we entered into the final state or not. The state is final state means we can say that the input string is accepted, otherwise the input string is not accepted. Here since Q3 is a final state, we can say that the Turing machine accept the input string 0 1. So the Turing machine accept the input string, and we have to check whether this is the equivalent MPCP instance for the given Turing machine. For that we need to check whether this MPCP instance has a solution or not. So solution means we need to check whether the list A and B has same string or not, right? This is the Turing machine. We are checking whether the Turing machine accept input string. Now we need to check whether MPCP instance has a solution. So we know that modified PCP means we have to start with the first pair. So hash, in list A we need to attach hash. In list B we have to write hash Q101 hash. So now we need to match this list A and list B. So we need Q10 in list A, right? So hereafter we can't use rule 1 because it contains only hash and here Q101. So hereafter we will use rule 2 and rule 3 continuously. When we enter into the final state, we may refer rule 4 and rule 5. So now we are going to refer only rule 3 and rule 2. So rule 3, we need to check whether we have Q101 hash. We have Q10. So we need to attach Q10 in list A and we have to attach 1 Q2 in list B. Then we need to refer 1 hash 1 Q2. Whether we have 1 hash 1 Q2 in list A. 1 hash 1 Q2, no. So we can use rule 2 for appending 1 in list A and 1 in list B also. If you are appending 1 in list A, this one we have to attach at the end of list B. Then we need hash 1 Q2. So check whether we have hash 1 Q2 in list A or not in rule 3. No. So we have to attach hash in list A and list B. Then 1 Q2 1 hash. 1 Q2 1 no. So we have to attach 1 and 1. So rule 2 means we can attach 0 in list A and list B, 1 in list A and list B, hash in list A and list B if we want. So we have to refer rule 3 always. So now we need Q2 1 hash. We have Q2 1 in list A, right, in rule 3. So we have to write Q2 1 in list A. At the same time, we need to write 0 Q1 in list B. So this string must be matched. Till that we have to continue this. So now check hash 10 Q1. No. So as per rule 2, we can attach hash and hash in both the list. Then 10 Q1 we don't have. So we have to write 1 and 1. Then 0 Q1 hash. 0 Q1 hash we have. So we have to write 0 Q1 hash in list A. As well as in list B, we need to write Q201 hash. Then 1 Q20 we have. So 1 Q20 and at the same time Q310 we need to write here. Then 1 hash Q3 no. So we have to write 1 and 1. Hash Q3 no. Actually we have entered into final state. So hereafter we need to refer 4 and 5. Okay. So hash Q3. Do we have hash Q3? No. So we have to write hash and hash. Then Q31. Yes, Q31. So we have to write Q31 here. And at the same time we need to write Q3 at the end of list B. Then 0, 1 hash Q3. We don't have. So we can write 0 and 0. So rule 2. As per rule 2 we are attaching like this. Then 1 hash Q3 we don't have. So 1 and 1. Then hash Q30 we don't have. So hash and hash. Then Q301, Q30 we have. So Q30. Here we need to write Q3 alone. Then 1 hash Q3 we don't have. So write 1 and 1. Then hash Q31 we don't have. So we have to write hash and hash. Then Q31 we have. So write Q31 here. And here we need to write Q3 alone. Then hash Q3 we don't have. So write hash here and here. Now we can use the rule 5 to attach Q3 hash hash in list A. And in list B we need to attach hash. Okay. So now our list A and list B, both the list contains the same string. So we can say that our MPCP instance has solution. Okay, so this is the equivalent MPCP instance for the given Turing machine. Thank you.